Welcome to Summarize Science. Today, we are looking at how researchers are pushing the boundaries of what is possible in the search for rocky exoplanets. They have implemented a significant update to an open-source tool called POSEIDON, specifically version 1.4. This tool is designed to help scientists understand the data coming from powerful observatories like the James Webb Space Telescope. In the past, many models used to study these planets had to choose between looking at a bare rock or a planet with a very thick atmosphere. This new update allows researchers to combine both, looking at how light reflects off the ground and then travels through the air and clouds. By doing this, the models can more accurately reflect the composite spectrum we actually observe from Earth. One of the coolest findings is that different types of minerals leave a specific fingerprint in the light a planet emits. These minerals can actually create features in the data that look like they come from an atmosphere, even if there isn't one. For example, a rocky surface can flip an absorption feature into an emission feature, which might trick astronomers into thinking a planet has a temperature inversion in its atmosphere. The researchers put this new tool to the test on two real worlds, TUI 1685b and 55 Cancri. For the planet TUI 1685b, the model confirmed it is most likely a bare rocky planet with almost no atmosphere at all. The light coming from it looks a lot like what you'd expect from a hot, airless version of Mercury. On the other hand, the data for 55 Cancri suggests something much more complex. The researchers found that this planet likely has a thick atmosphere rich in carbon dioxide, which traps heat and alters the light we see. Being able to distinguish between thin and thick atmospheres is a major step forward for planetary science. The study also explored whether the James Webb Telescope could eventually tell us exactly what kind of rock is on the ground. By simulating more observations, the team found that with enough data, we could distinguish between a surface made of granite and one made of basalt. On Earth, granite is often associated with plate tectonics, so finding it on another world would be a massive discovery. To make this all possible, the researchers compiled a comprehensive database of how different minerals reflect light across many wavelengths. This database includes laboratory measurements for everything from volcanic glass to common clay and salts. It acts as a library that astronomers can use to match the light they see from space with real-world materials. So, what does this mean for the future of space exploration? It means we are moving from simply discovering planets to actually understanding their geology and history. By merging the fields of geology and astronomy, this research provides a pathway to probe active processes on other worlds. In summary, researchers have updated the POSEIDON code to model both surfaces and atmospheres together. They proved that rocky surfaces can mimic atmospheric features, making these new models essential for accuracy. They successfully applied these models to planets like 55 Cancri, confirming the presence of thick atmospheres. Finally, they showed that future missions could identify specific rock types like granite on distant worlds. This is just the beginning of the Rocky Planet Picture Show, and it brings us one step closer to finding a truly Earth-like world. Thanks for watching Summarize Science.